So as you can see, the cobalt has oxidation state of +3, so that means it has lost 3 electrons. So the electrons that cobalt loses is 2 electrons of 4s, sorry, I've shown it one more electron here, no, and 1 electron of 4s. So there is no electron over here, and there are 2 electrons. So when the ligands approach, that is the ammonia, it approaches the cobalt, its energy level increases, and the pairing of these electrons takes place. As we have seen that the strong ligands, they cause pairing, and now we have this ion in this state where these two orbitals are free and 1s and 3p orbitals are free, because we need 6 orbitals to accept 6 pair of electrons from the ligands. So now what happens as hybridization takes place? G2, S and P3. So the final complex is formed something like this. These 3 orbitals are filled with the electrons from metal itself, whereas these 6 orbitals, they contain electrons which are accepted from the ligands. And as we can see, there is no unpaired electron. The magnetic moment will come out to be 0 and the complex will be diamagnetic. Here you can see that the orbital we are using for hybridization belong to the inner d orbital, so that is why it is inner orbital complex or spin paired complex. And another example I have is of nickel ammonia 6. Again we have the ligand is same in this case, and it is again the coordination number is 6. So nickel here is in +2 oxidation state. As we have already seen, the atomic number of nickel is 28, and +2 oxidation state means it has lost 2 electrons from the 4s orbital. Now the ammonia is a strong ligand. It can easily cause the pairing of these 2 orbitals. Understand this part very clearly, that ammonia can very easily make these 2 orbitals electrons pair, and it will have 1 d orbital over here, right? But it does not need only 1 d orbital. How many d orbitals it needs? It needs at least 2 d orbitals, because it can use 2 d orbitals plus 1s and 3p. Then it will manage 6 orbitals for forming 6 bonds to the 6 ligands. So it will not serve any purpose to the ammonia if it will force these 2 electrons to pair. So instead of this process, what happens, that nickel uses its outer d orbitals, the orbitals of 4th शेल यानी आउटर मोस्ट शेल के जो डी ऑर्बिटल्स हैं उनको यूज करता है, और हाइब्रिडाइजेशन क्या होती है? एस पी के 3 और डी के 2. इसको हम क्या बोलते हैं? sp3d2. इसमें डी बाद में आता है बिकॉज इट इज द आउटर शेल डी ऑर्बिटल्स विच आर यूज्ड. एंड हमारे पास क्या आ जाते हैं यहाँ पर? 6 इलेक्ट्रॉन्स 12 इलेक्ट्रॉन्स, 6 पेयर्स वी ऑब्टेन फ्रॉम द लिगेंड्स. इसकी sp3d2 हाइब्रिडाइजेशन है, बट स्ट्रक्चर इसमें भी हमारे पास क्या है? आउटर हेड्रल. इसको हम बोलते हैं आउटर ऑर्बिटल कॉम्प्लेक्स और हाई स्पिन कॉम्प्लेक्स. सो दिस इज हाउ जो वैलेंस बॉन्ड थियरी है, इट हेल्प्स अस टू नो अबाउट द हाइब्रिडाइजेशन, नंबर ऑफ अनपेयर्ड इलेक्ट्रॉन्स, मैग्नेटिक मोमेंट. यू कैन इजिली कैलकुलेट द मैग्नेटिक मोमेंट ओवर हियर. इट हैज 2 अनपेयर्ड इलेक्ट्रॉन्स, एंड ऑल्सो you can know that this complex will be diamagnetic. So but it has various limitations. Those limitations we'll be studying in the class, where we will see that how those limitations then led on to the formation framing of crystal field theory. Okay, I hope you understand. Please do it. आप थोड़ा घर में भी इसको डिस्कस कर सकते हैं with other examples. आप खुद ही कोशिश कीजिएगा इसको सॉल्व करने की.